Okay, guys, even if the instruction didn't say anything about not using a calculator, could we use a calculator for that one? No, because there's an x here and there's an x there. Okay. So, guys, we need to have a sine equals sine so that we can say that that second angle is our reference angle, right? Currently, we have a sine equals cos. So, just like in the previous one, we're going to have to change this one to a sine. A sine of a 90 minus.
Is there any way to change sine to a cos?
You could, yes, yeah. I just want to show you kind of this one with the brackets. But yes, you could have changed the sine 2x to a cos 90 minus x. Or 90 minus 2x. Yeah. Now guys, what makes this question difficult is that I'm going to have to change it now to a 90 minus brackets x minus 60. Right? Remember when we are subtracting multiple terms, we need to keep those terms in a bracket. Okay, so I'm going to have to do this. I'm going to have to say this is sine 90 minus x minus 60, like that. You can use 2 pairs of round brackets if you want to. I just personally prefer using square brackets. And now what must I do with that minus? Multiply it into the brackets, right? So I'm going to get sine 90 minus x, and then a negative times a negative is a positive 60. So I'm ending up with 150 minus x. This is now going to be my reference angle. 150 minus x. It's unfortunate that it consists of 2 terms, but it's okay. We're going to use the exact same method. What happened now? I could see that, yes. Alright, we're working with sine. Guys, this is a positive. Okay, there's not a minus there. So we're working in the positive quadrants. My reference angle is going to be 150 minus x. Okay, so quadrant 1. What angle is after sine on the left? 2x. So 2x is equal to, remember quadrant 1 is just the reference angle, so 150 minus x plus 360n. Now I must get all the x's on the one side. So this minus x is going to become plus x. So we're going to have 3x equal to 150 plus 360n. And now we must divide all of that by 3. Plus 120n. There we go. So that is the first one. Our first quadrant general solution. Okay, quadrant 2. You can leave open a line if you want to as well, guys, because our calculations are a little bit longer for these ones, but you don't have to. So again, 2x equal to, now in quadrant 2, it's 180 minus the reference angle. How many terms does my reference angle consist of? 2. So we have to put it in brackets, please, so that we subtract both of those terms. So 150 minus x plus 360n. So 180 minus 150, when I multiply this minus n, it's going to become a minus, right? So that's going to give us, you can write the answer already, but let me rather just do this properly. What is a negative times a negative? Positive x plus 360n. Okay, so 2x, this plus x, when I move it, is going to become minus x. So 2x minus x is x. Okay, so that one works out nicely. What's 180 minus 150? 30 degrees plus 360n. Now, guys, these are my 2 general solution formulas that I'm going to use to get specific solutions, right? Because this question again was asking for specific solutions between negative 180 and 180. All right, so I'm going to have to use that formula there, and then I'm just quickly drawing my arrow there. Oops, that's not very neat, but you get the idea. Okay, so both of those formulas, I'm going to have to sub in n values to get me those specific solutions. Guys, I want you to do that on your own quickly, please, with your calculator like I showed you. Type in 50 plus 120 with your bracket, sub in n values, and write down all the ones that you get that lie between negative 180 and positive 180. All right, those are the answers that I got. Do we agree with those 4? All right, so I actually got 3 from my first equation, right? And guys, the reason for that is because of the 120 in front of the n. You're not adding as many degrees each time. So this one was from the quadrant 1 solution when n was 0. The second one was the quadrant 1 solution when n was 1. And the third one was when n was negative 1, right? And then I only got 1 from my quadrant 2 solution. So this was when n was equal to 0. Guys, for each one that you leave out, it's normally 2 marks for all of them. And then when you leave out 1, you lose 1 mark. So if you leave out 2, unfortunately, you lose both of those marks. Okay. Or if you've added 1 that shouldn't be there, they also minus a mark. All right, I'm quickly going to show, and also guys, thank you actually for mentioning that. Did we notice that it was cos x minus 60, which is technically a compound angle, but I didn't expand this using the compound angle identity, right? What a mess it would have been if I had done that. Let me quickly show you if we did that. So if I had sine 2x equal to cos x minus 60, please don't write this down because I don't want you to ever think that you have to do that. But if I expanded this, I would get cos x times cos 60 plus sine x times sine 60. And now what? Now we would think, okay, let's use our special triangles, right? Let's write that cos 60 is root 3 over 2. No, half, sorry. Plus sine x times root 3 over 2. And now, am I actually able to solve that equation? No, right? We can't really separate this cos x from the half, and we can't separate the sine x from the root 3 over 2. So guys, I want to actually, let's just write next to, if you have some space next to this example over there, or above it maybe, or underneath it. With trig equations, guys, never expand a compound angle. Okay, never, ever. So for trig equations, never expand a compound angle. Oops, sorry. Right, you don't have to. You can change that to a sine 150 minus x and then very easily just get your reference angle from that. And in the same way, guys, this sine 2x, I also didn't expand that one, right? Because that's a double angle. I could have changed that to 2 sine x cos x, but again, that wouldn't have helped me. All right, that would have made the whole thing much more complicated. Sometimes, we'll do an example like this tomorrow, sometimes they give you the expansion of a compound angle, right? So they'll give you something like this. Let me show you. They can give you, we'll do an example like this tomorrow, so don't worry about copying this down. Sometimes they can give you this as a question. A compound angle that has already been expanded, right? And then what you'll have to do is you will have to put it back together into the compound angle, into the brackets, so that you can do your sine equals sine thing. Okay, but you will never in a trig equation have to take a compound angle, the brackets, and expand it. Okay.